good times and also getting ready for our test. We're multitasking. I love that for us. Okay, let's warm up. I am going to go to 2 shows this year. And I would like to increase my fangirling at a rate of 50%. Write an equation for a geometric sequence that shows this. Okay, so remember your basic equation, and maybe this is something that goes on your note card. A sub n equals a sub 1 times r to the n minus 1. So that's your basic formula for a geometric sequence. I would definitely have that on my note card. And again, if you're titling it as what it is the basic formula for a geometric sequence. Just the formula if you were writing like an explicit equation. Okay, for this problem in particular, a sub n equals, what is my first term? What's my a sub 1? 2. My a sub 1 is 2 times the rate. So the r I'm thinking of like a rate here. What is my what am I multiplying by? 1.5, because I'm going to go to 50% more. So kind of almost thinking back to the unit we did so long ago when we did exponentials and logarithms, right? Chapter 4. And then that is raised to the n minus 1. So the nice thing about this formula is that it's now set up for you that you could find any n value you so choose. If you want to look way down the road and think like, what's 20 years later look like? What's 30 years later look like? You can plug in all those numbers because I have my a sub n, I have my general equation. Okay, so for the next part, what I said was, do the problems, but obviously I'm not going to attend like a partial show. You could leave in the middle, right? So I said round up to the nearest natural number. So you can put this into your calculator if you want, or you can do the math for each one individually. It doesn't matter. Here's my equation plugged into my calculator. Do you see how it matches what I just had? If you have old software, you need parentheses around the x minus 1. And then I'm going to go to my table, and I'm going to find my values. So it wants me to find the first 5. So I'm going to find A1, A2, A3, A4, and A5. And we talked about the fact yesterday that part of the reason I made this a test is because there are so many different little things you have to do, and not that any of them are super tricky, but it's a lot of facts for me to give you points, and so the point total just doesn't suggest a quiz to me. Alright, so here are my values. So A1 is 2, so year 1 I went to 2, but we already knew that. Year 2, I'm going to go to 3. And then year 3, I'm going to go to 4.5, but I said round up because, you know, doesn't make sense to go to 4.5. Gotta stay for the full show. Year 4, rounding up to 7. And year 5, rounding up to 11. What would be the 10th term? So if we went way down the road and found the 10th term. So again, I could use my calculator, or I could even plug it into this formula, right? So I'm going to plug it into the formula because I wasn't doing that a minute ago, so I want to model what that looks like. So if I plug it into the formula instead of looking at my calculator, I plug in 10 in place of n. So this is going to give me my a sub 10, my 10th term. And so on my calculator, again, if I didn't have the equation typed in, 2 times 1.5 to the 9th power. So that gives me 76.88, and remember we're rounding up. So I'm going to have 77 shows. That might be expensive. Okay. For part D, I said write the sigma notation. Remember, sigma is summation. So it says write the sigma summation showing the total number of shows. Now, I had some people asking, like, are we using these numbers from part B? No, I said just use this equation from part A to find the total number. Okay? So, for the sigma notation, again, going off of part A, not off of part B. So there's my sigma. I started on what year? year 1, and I'm going how many years into the future?
10 years.
10 years into the future. And my equation that I'm basing it off of is this. That's how I'm finding everything. So in parentheses, 2 times 1.5 to the n minus 1. I'm a big proponent of putting parentheses around things when I'm taking a sigma notation, so I know it's this whole thing. Like that whole thing is included in what I'm finding the values of and then summing up. Okay. Based on the r value, does it converge or diverge? Diverges as we go to infinity. So if you don't remember how to figure this out, if the absolute value of r is greater than 1, we diverge. So think about r. What's my r value here? 1.5. Is 1.5 bigger than 1?
Yep.
Yep. And then if we had the absolute value of r is less than 1, then it converges. And truly, when we are taking the absolute value of something, it's going to be less than 1, but can it ever even be less than 0? No. So that's going to be a fraction or a decimal that lives in between 0 and 1. Does that clear things up on the first part? Yes, we're good? Okay. Alright, next. I'm going to a concert. The theater has 22 seats in the first row and 4 additional seats in each row. Write an arithmetic sequence. So this is your a sub n equals a sub 1 plus n minus 1 times e. Again, that's something I would have on my note card. That's your basic formula for an arithmetic sequence. You can share their equation with me that they think is a match to this.
A of n equals 22.
22 plus, let's do the parentheses, yeah.
Minus 1.
N minus 1
Times 4.
times 4. Now, if I wanted to, could I simplify this a little bit more?
Yeah.
Yeah. Do I have to? No. So it's kind of one of those up to you. So if you would like to leave your answer like this, that's lovely. You could also say a sub n equals 22 plus 4n minus 4. A sub n equals 4n plus 18. When I combine my like terms, right? The 22 and the minus 4, I end up here. So I am fine and would give full credit to this answer or this answer. You don't need both. One or the other is lovely. We good so far on that one? Okay. So this one is arithmetic the whole way through. A1. How many seats were in row 1? 22. In row 2? 26. In row 3? 30. So we're adding 4 on every time. In row 4? 34. In row 5? 38. Now, could we brute force and keep going up to a sub 10?
Yeah.
But especially if that was even bigger, right? Like if we were looking at an even bigger term, we might not necessarily want to do that. So instead of brute forcing, what I'm going to do is go back to my equation. Again, you can use either one. You'll get the same answer. And I'm going to plug in 10. So this would be 4 times 10 plus 18, which gives me 58. So I have 58 seats in the 10th row. All right, how many seats total are in the first 25 rows? There are 2 different formulas that you can use here. Let me pull the notes out for just a second so you can see both the formulas. They are in section 2.2. They were on the second day of notes that we had. So we had 2 different formulas. So hold on, let me switch out for this for a second. So here's your second day of 2.2 notes. And let me zoom out just a little. Okay. You have 2 different formulas. Remember S sub n. N stands for how many partials, or how many terms you're going to add up through. It stands for your partial sum. So if it's S sub 10, you're going to add the first consolidate, you'll add the first 8 up. Remember, you can use either one, and sometimes one is more conducive than the other, depending on what you're given. But either formula is perfect, and you'll get the same answer. Doesn't matter which one you use. Again, something that I would have on my note card. Also thinking about the note card, if I were making it, I would have like my arithmetic stuff together. So maybe one side is arithmetic and the other side is geometric. And if you've already started and you're like, yeah, I want to do that, but I didn't, let me know. I've got extra note card pieces. Well, I don't yet, but I will in a minute. And you can have a new one. But again, I might organize one side arithmetic, one side geometric, because then that way you could go to the side that you need. Okay? Alright. Here we go. So in the first 25 rows, so I think I'm going to use this formula because then I don't have to calculate anything. The n over 2a1 plus n minus 1 times the constant difference. Okay, what goes in for n for this problem? 25. So 25 divided by 2. 2 times a sub 1. What was my a sub 1? 22. There were 22 seats in the first row. Plus n minus 1. What will that be? 25 minus 1. Times the constant difference. What are we increasing by? Positive 4. So make sure that you type it into your calculator correctly. When you do, I got 3,150 seats, which is obviously not enough because so many people want to go, right? Not enough is the answer, but the specific answer is 3,150. I did. But it shouldn't matter which formula you use. You got 1,000 too? Oh gosh. Okay. Hold please. Okay, so we've got 25 divided by 2. That gives me 12.5. Oh, I think I know what I did already because I think I put in 22.5. I know what I did. 44 plus 24 times 4. Oh, I too get 1,750. I know what I did. I put in 22.5 instead of 12.5. It hit me as yeah. Putting in the wrong number will do it. There we go. Still not enough seats. That's true. So many fans, not enough seats. Alright.